Okay, so this is problem 5 of the HMMT TST. We let S be the set of real numbers x such that both the function x cubed minus 4x squared minus x and x cubed minus 3x squared minus 3x plus 1 are integers. We want the product of all numbers in x which are not integers. So obviously if x is an integer, then both of these are integers. We want the non-integer values that give an integer. So first, something that people would notice is that like this looks awfully something like x plus 1 cubed or x minus 1 cubed, but you find out that because of like the negative signs, you notice that it can't actually, like, it's not relevant that it looks like 1 3 3 1, which is x plus 1 cubed. So now we if we let the functions be f of x and g of x, we know that both of these are integers, so we use this notation to denote that they're both integers. So we can do some functions on integers and still get out integers. For example, we know that their difference, so f of x minus g of x, must also be integers, must also be part of the integer set z. For example, if you have like 5 minus 3, it obviously equals 2. If you have an integer and an integer, you can do like addition, subtraction, multiplication, and it'll still be an integer. So we subtract f of x minus g of x, and we get negative x squared plus 2x minus 1. So I did that. Like here, you can do it with scratch paper and confirm that it's this. So that's what this is. And some of you may notice that this is actually a very nice expression because it's equal to negative of x minus 1 squared. So negative x minus 1 squared must be an integer. Now, we don't particularly care that there's a negative here because if you have an integer and you take a negative of it, it's still an integer. If you have an integer and you take the negative of it, it's still an integer. And if you have something that's not an integer, the negative of that is also not an integer. So we just want x minus 1 squared to be an integer. And how does this work? Well, obviously, if x is an integer, it works. But we know that x is not an integer, so what do? Well, let's say look at x minus 1. That means x minus 1 must be the square root of an integer. So let's write x minus 1 to be the square root of k. Therefore, we know that x is of the form 1 plus square root of k, where k is an integer. And now we can plug it back into our, for k is any integer that is positive, because you can't have the square root of a negative number, or non-negative at least. So it's in the integer set z, and it's non-negative. Now we plug it back into either one of these equations. I'm going to do this one because it's easier. So we know that f of x is an integer, which equals to f of 1 plus square root of k, which equals to 1 plus square root of k cubed minus 4 times it squared minus itself. And at this point, you can just expand it out using traditional algebra methods. So it's k root k plus 3k plus 3 root k plus 1 for the cube term. And then for the square term, it's minus 4k minus 8 root k minus 4. And then for the last term, it's minus root k minus 1. So overall, we get k root k. And then here we have 3k minus 4k equals negative k. And then here we have plus 3 minus 8 minus 1. So it's minus 6 root k. And then here we have 1 minus 4 minus 1 equals minus 4. So we know that this must be an integer. Well, first of all, the 4 doesn't matter because we already know that 4 is an integer. So we also know that k is an integer, so we can get rid of k. So we just want k minus 6 times the square root of k to be an integer. And now what do we do? Well, we know that k is an integer. We also know that square root of k is not an integer, because if square root of k, for example, if square root of k is an integer, then we know that x is also an integer. So we know that this must be not an integer. Well, not an integer multiplied by an integer is still, like, it's not only is it not an integer, it's not rational because it's the square root of something. So here we know that k minus 6 must be 0. So we can do k equals 6, and we get x equals 1 plus square root 6. Well, hold on. Is this the only solution? Well, it's not, because if you look back to where we came from, we have a squared here. So we know that k is always 6. But that means that x minus 1 on the inside doesn't have to be square root of 6. It could also be negative square root of 6. So if k equals 6, we can also have x equals 1 plus negative root 6, or 1 minus root 6. These are our two solutions. We multiply them together. We get 1, by the difference of squares, we get 1 squared minus square root of 6 squared equals negative 5 for our final answer.